Control Z. Control Z and then it'll all appear again.
Now, I'm just going to quickly go through it with you. If you started writing it, then good. Just follow along easier. So remember, this means f of -1 plus g of -1, correct? So we have f of -1, which is 6 times -1 squared minus 2 times -1. And then we have g of -1, which means 3 minus 1 over -1. And so this simplifies into 1 times 6 and 2, so that's 8, right? And that simplifies into -1 by subtracting -1, so it's 2. So we're adding 2. So we get 10. I always write it out different when I do it again, but it's the same basic problem. I think I showed it. So that was just adding two functions together. This one is multiplying. So it means we're going to do f of 2, and we're going to multiply g of 2. So f of 2 is 6 times 2 squared minus 2 times 2. And g of 2 is going to be 3 minus 1 over 2. And we're multiplying this times this. So that's 4 times 6 is 24 minus 4, so it's 20. And then this one's 3 minus 1 half, so that's 2 1/2, or 2.5. So 20 times 2.5 is 2 1/2 times 2 1/2. And it should equal 50. That's what we had up here earlier, right? It's just a lot of arithmetic on some of these, just plugging it through. Okay, let f of x equal that, g of x equals that. Same thing, we're just subtracting this time. Okay, so the difference between the instructions on example 2 and the instructions on example 3 is that this time we're going to look at the domain, see if that has been affected at all by what's happened. So let's first look at function f. Is there anything that affects the domain of f? F is just 6x squared minus 2x. What three things do we talk about that can affect the domain that we need to watch? Square roots, fractions, logarithms. Good. So does function f have any of those three things? Nope. So guess what the domain is? All the numbers, -infinity to positive. Okay, let's look at function g. Does it have any of those three things that can affect its domain? It has a fraction. And it has a variable in the fraction. That's when it's important that it affects the domain. So we can't divide by 0. And currently there's an x in the denominator, which means x cannot be 0. So just based on that right there, the domain for this piece right here is that, I need that extra parenthesis, is x cannot equal 0. So guess what that means? When we combine these functions together into a new function, that means that our new function, x cannot equal 0. The domain of one of the parts affects the domain of the whole. Okay, so we're just going to do, I guess the other difference between this problem and the ones we were doing is we were actually plugging in numbers. This time we're not plugging in actual numbers, we're just using the variables and the expressions we already have. So we're taking g of x and we're subtracting f of x. So we get g of x, let's make sure we start with the right one first. And then we're subtracting f of x. Now be careful. If you subtract something, you must not forget to distribute the negative through as part of that subtraction. So, in other words, we're not subtracting subtracting 6x squared and then subtracting 2x, what is subtracting 2x doing to that 2x? It's going to be adding 2x instead. So we're going to have 3 minus 1 over x minus 6x squared plus 2x, because that negative affects that sign right there and changes it to a positive. Is there anything else we can simplify? Do we have any like terms? We do not have any like terms. So we're done. It's as simple as it gets. And the domain of g minus f of x is that x cannot equal 0. And the reason it can't equal 0 is because the domain of g of x is that x can't equal 0. We now have that 1 over x as part of our new function. So the domain is still affected by that. All right, last one is division. Again, we could look at the domain. We already talked about it right here. So domain of g of x is that x cannot equal 0. So we'll keep that in mind as we simplify this next problem. So we're going to do g of x divided by f of x. Problems like this are one of the reasons you have to placement test into this class. They kind of want to know that you have some algebra skills already that are not going to slow you down in learning new things. So we need to simplify this expression. We don't usually like to leave fractions in fractions. We have a fraction in our fraction. That's just kind of not good manners in math. All right, so you remember last year how to get a fraction out of a fraction. Well, we honestly need to make the entire numerator into one fraction instead of as a 3 minus 1 over x. We want it to just be an all-encompassing fraction on its own. So let's do a little side note. So 3 minus 1 over x is the same as 3x over x minus 1 over x, which is the same thing as 3x minus 1 over x. Did I lose any idea? That's just the numerator. So the numerator is 3 minus 1 over x. So I want a common denominator. So I multiply the top and the bottom of the 3. There's the bottom, put it over 1. Multiply by x over x, so that we have a common denominator of x, which changes our numerator to this. The reason we want to do that is so that we can then divide this fraction, because we now have it all one big fraction, divided by this thing. And to do that, we're going to use division of fractions, which is where you keep the numerator the same, and you flip the denominator. You multiply. Do you remember learning that? Where you multiply the reciprocal. When you divide by a fraction, you multiply by a reciprocal. And I realize we're not actually dividing a fraction. Our denominator is not a fraction, but our numerator is. So we need to treat it like it's a fraction over a fraction, even though it's just going to be like over 1. Okay, so that gives us 3x minus 1 over x. There's our numerator. And we're going to times by the reciprocal of the denominator. So right now, the denominator isn't a fraction. To make it a fraction, it would be over 1. So how do we make it a reciprocal? So this right here is the reciprocal of our denominator. Yeah? Makes sense? I kind of summarized this with, yeah. Well, no, don't take it yet. Oh, maybe. I guess I don't have this class clean, do I? You're good. Do you want to take these two?
Yeah, you also don't have next class. So.
I don't. That's right. I forgot I don't make these days clean because I don't have the first clear. up for me too. I usually use some clocks for them. All right. Lovely little interaction in our video. We're good. So we have copy the numerator, dot, change it to multiply, flip to do the reciprocal, and that's how we divide, because a fraction means divide. To simplify this. Ugh. Okay. So that gives us 3x minus 1 times 1. Denominator's not really that bad either, because it's just going to be x times 6x squared minus 2x. So 6x cubed minus 2x squared. Alright. Gosh, why do we have to have a problem with so many complications? You would think we're done, right?
No.
No, not done. Now we can factor something out of the denominator. Factor out of 2x squared.
Okay.
So if we factor out 2x squared out of the denominator, 6x cubed divided by 2x squared is 3x. And negative 2x squared divided by 2x squared is negative 1. Well, would you look at that? Huh?
Yeah.
How are you so fast? Are you not
No,
taking it down?
they said that they'll just come and get it at the beginning of fourth.
Oh, who, Miss Robinson?
I guess.
Yeah, she's pretty gathering them all up. You could go refill my bottle though if you wanted to, so she doesn't have to worry about that, because it's a big line down there, it's a pain. Unless you really don't want to. Oh. So here is our simplified answer. That big ugly thing turned into this. We're not done till we talk about domain. Okay, we know from this that we can't plug in 0. And actually look at our answer right now, we still can't plug in 0, right? There is another issue in this problem. Even though this canceled out, that is still part of the problem, part of the process. So we need to worry about the fact that 3x minus 1, we also don't want that to be 0. So I think in addition to the fact that x can't equal 0, also x cannot equal 1/3. Because what would have happened if we plug in 1/3 to this original problem? Let's try it. 6 times 1/3 squared, oh really, so that's going to be 1/9, so 6 ninths, minus 2 times 1/3, 2/3. Does that work? 6 ninths minus 2/3. Oh yeah, 6 ninths is 2/3, right? What happens when I take 6 ninths and I subtract 2/3? I get 0. So since this would make the denominator, 1/3 would make our denominator 0 in that step right there. Even though that canceled out here, we still can't include that in our domain. There's a hole right there. Because we can't plug a 1/3 into this problem without dividing by 0. A little bit weird. Yeah, kind of annoying. Okay. Let's just kind of preview. Oh, difference quotient, we didn't get to that point. I don't know why students hate the difference quotient so much. I don't like it as everyone thinks it is. Maybe that's just difference quotient. The reason you've not heard of difference quotient is because it's a calculus. So why are we doing that in this class? This is a calculus. Well, this is pretty smart. So a lot of you will be taking this class instead of like Math 230 because it allows you to move on to calculus. And so this is something you'll see in calculus, and so we're learning to work with it now. we don't know what it means yet because we're not learning about the actual different explosions and how we use it in calculus. It has to do with finding the rate of change on a graph at some point. But we are going to learn how to find the different explosions. Okay, so obviously we're out of time, and we will just have to do this rest of section 1.4 next time. This kind of happens. Chapter 1 is packed full of stuff. You probably learned last year, but maybe not in quite so much depth. So we're just making sure we understand that depth, because all of these things we're learning in chapter 1 are going to apply to every chapter of functions from here on out. We're going to start studying specific functions in each chapter. And each chapter with those specific functions, we're going to be doing symmetry and x and y intercepts, and we're going to be doing function notation, and we're going to be doing transformation, and we're just going to see all of that all the way through. So that's why we're just hitting all those properties now. It's a little overwhelming, along with the beginning of year, getting used to class, figuring out distance learning, and getting tested into the class, all that stuff. So we should be able to make up for the time later. I don't want to rush us through this beginning stuff. We'll be okay. All right, I'm going to check on our online class members. I do want to